In Chapter 8, we are going through air quality issues together. And without understanding the basic components, water and air, it's impossible to discuss environmental problems. So these two chapters are very heavy. That's why the lecture is longer and the course content is more, but I think that's vitally important to understand the environmental problems we're facing now. So after we learn this chapter, we're going to be able to describe the 4 layers of atmosphere and understand about weather. My focus of the chapter will be primary and the secondary pollutants. And we're going to understand how photochemical smog happens and what's the consequence of that on acid deposition, the acid rain. And then we'll take a quick look at the different policies aimed at improving air quality. So air pressure, the more gas molecules in the balloon, the higher pressures we have inside the balloon. And all gases move from areas of high pressure to low pressure. And it is very interesting, most of the gas molecules are in the first layer of the atmosphere, which is a troposphere, because of this gravity pull. And all of us need to understand the composition of the air, the gases in the atmosphere. Majority is nitrogen. Nitrogen is not very active. And we humans cannot utilize nitrogen directly from the air. And a lot of living organisms cannot. The heroes helping us to utilize the nitrogen from the atmosphere is a group of bacteria called nitrogen-fixing bacteria. Only that group of bacteria can directly convert nitrogen to the nutrients to all the lives on Earth. So it is interesting, we are like immersed in this inactive nitrogen, and 1/5 of the whole atmosphere is oxygen. So the oxygen is about 20%, and that's a perfect concentration for us. When the concentration is higher, actually, we can get poisoned by pure oxygen. And about 1% of other gases such as argon, carbon dioxide. And it is very interesting. If you look at the percentage of carbon dioxide, it's very low. But it's a very powerful greenhouse gas. And we have some water vapor, we have a bunch of other gases, methane, but majority is nitrogen and oxygen. The atmosphere has 4 layers. Troposphere, we are living in the troposphere, where this is the most active zone for weathers. And then the second layer is stratosphere. And this blue haze, that is ozone. And this is the first time in this lecture I have to point out to you. When the ozone is present in this layer of atmosphere, it's very protective to us because it reflects the UV radiation. We're going to talk about another form of ozone which is very harmful for us. It's called ground level ozone. So don't mix them up together. Okay, so the ozone in stratosphere, that is very beneficial to living organisms on Earth. And the third layer is mesosphere, and the fourth is thermosphere. So one sentence about each troposphere, about each layer. In the troposphere, this is where the weather happens. Because of this very active air movement. Okay, when the air cools and sinks, it forms a high pressure system. And when the air warms and rises, it forms a low pressure system. Stratosphere, as I just mentioned, we fly airplane here because there's not much active air movement as in the troposphere. It's pretty peaceful. That's why we fly our aircrafts in that layer. Mesosphere. So the mesosphere is 50 to 80 kilometers above us. So the feature of this layer is it's very cold. You can see a thermometer here. Okay, this is a very cold layer where meteor showers happen. Because when those meteors pass through the atmosphere, they will burn. So we see those beautiful showers. And the thermosphere, from the name thermal, it means hot. And it is a very hot layer, as we can see here. It's about 1500 degrees Celsius. And in this layer, we can see this is where we put our spacecraft in, and those astronauts can see those beautiful auroras because air is very thin in that layer, and they become ionized when they contact with the sunshine. That's why we see those beautiful auroras. So this concludes my first part of the lecture, a brief introduction of the atmosphere.